Welcome back, everyone. So, we will discuss a chapter from the next book of Human to Computer Interaction, which is called Reducing Work and Eliminating Exercise. Introduction. The goal of designers, or at least one of the more important ones, is to minimize that work while at the same time enabling users to achieve their goals. They will struggle to relate their mental models of the activities they want to perform to the product interface that has been engineered. So, one of the goals of the designers is to remove the small efforts that the user gets when trying to achieve their goal. So, later we will explain that. User perform four types of work when interacting with digital products: cognitive work, comprehending product behaviors, as well as text and organizational structures; memory work, recalling product behaviors, commands, password, names, and locations of data objects, and controls and other relationships between objects; visual work, figuring out where the eye should start on the screen, finding one object among many, decoding layouts, and differentiating among visually coded interface elements such as lists, items with different colors; physical work, keystrokes, mouse movements, gestures, click, drag, double click, switching between input modes, and number of clicks required to navigate. When implementation model thinking is applied to digital products, these four types of work are seldom minimized for users, quite the opposite, in fact. The result is software that, in effect, charges its users a tax or excise of cognitive and physical effort every time it is used. So, there is an implementation model. So, if you do not know what it is, it's the treating of the mechanical age or what has been done in the past to apply in this digital technology, because usually in these digital tools you can immediately do the thing that you need to do instead of going or doing things physically, such as when you're going to work, you need to open the door, open the garage, and then drive your car. So those are the things that does not need to happen in digital world, because you can immediately do your task. So essentially, this chapter is about minimizing those extra things that we got from mechanical age, such as implementation model thinking, to now on digital age. So we're bending the rules of physical laws and then applying what's possible in digital tools. So these are the four main work or that we do. So these four types provides different types of cognitive load. Goal-directed task versus exercise task. Any large task, such as driving to the office, involves many smaller tasks. Some of these tasks work directly toward achieving the goal. These are tasks like steering down the road toward your office. Exercise tasks, on the other hand, don't contribute directly to reaching the goal, but instead represent extra work that satisfy either the needs of our tools or those of outside agents as we try to achieve our objectives. So as we try to achieve our objectives, there are different things that our new tools needs to be satisfied, such as opening the garage, etc. So we will gonna minimize that in this chapter. Software 2 has a pretty clear dividing line between goal-oriented task and exercise task. Like automobiles, some software exercise tasks are trivial, and performing them is no great hardship. On the other hand, other software exercise tasks are as obnoxious as fixing flat tire. Installation leaps the mind here, as do such exercise tasks as configuring networks and backing up files. So these two, later we will discover that we need to remove that to the user as much as possible, because they don't need to do those things. We can do like apply um, something that will help them instead of having them do it. Types of excise: eliminate excise wherever possible. The existence of excise in user interfaces is a primary cause of user dissatisfaction with software-enabled products. It behoves every designer and product manager to be on the lookout for interaction excise in all its form and to take the time and energy to see that it is eliminated from their products. Navigational excise: navigation through functions or features of a digital product is largely excise, except in the case of games, where the goal is to navigate successfully through a maze of obstacles. The work that users are forced to do to get around in software and on websites is seldom aligned with their needs, goals, and desires. However, well-designed navigation can be an effective way to construct users about what is possible to them, which is better aligned with their goals. In fact, our opinion, poorly designed navigation presents one of the largest and most common problems in usability of interactive products, mobile, desktop, web, or otherwise. It is also the place where the developer's implementation model typically is made most apparent to users. Navigation through software occurs at multiple levels. So this is where the developer provide the most impact in their implementation, which is in navigating how the customer navigate the website. So it navigation through software occurs at multiple levels across multiple windows, views, or pages, across multiple panes or frameworks within a window, view, or page, across tools, commands, or menus, within information displayed in a pane or frame, such as scrolling, panning, zooming, following links. We find it useful to think in terms of broad definition of navigation: any action that takes the user to a new part of the interface or that requires him or her to locate objects, tools, or data elsewhere in the system. So anything that takes the user to a new part of the interface. So any different views that requires him to locate objects, because remember, objects are the data. In the next future chapters, we will discuss how this objects relates to affordance. So the more obvious the objects the control is, the less cognitive load it has. Therefore, provides us a better navigation on the website. And also, we will also discuss how this all of this is just a perceptual, just like we discussed in the previous video, perceptual beauty of our website that adds cognitive load to the user. So it doesn't really affect our function. A lot of websites have terrible navigation or perception or perceptual beauty with their website, but you can still use the function. However, the issue is they will turn to other websites that provide a better perceptual beauty because it is less cognitive demanding. Navigation across multiple screens, views, or pages. Moving across multiple applications, views, or pages is perhaps the most disorienting kind of navigation for users. It involves a gross shifting of attention that disrupts the user's flow and forces him into a new context. So moving pages in the websites. So websites consist of different pages, and web application is an interactive websites. It has more features, but later we will discuss that. But basically, this rough flow. So we will discuss. Sorry, not we will discuss that website. I think we've discussed that in the previous video. But for the flow, the user's flow, we will discuss this in the future video. Basically, the idea is that whenever we use this application, we use this for productivity. We want to achieve a goal, and therefore we enter into a state of flow where we are so focused and we don't want to be distracted. So changing view or page distract us. So you don't want your application to do that. The act of navigating to another window also often means that the context of the original window are partly or completely obscured. So if you move to another window, it means that you will hide the original window, which distract flow, and it takes a lot of cognitive load because you need to go back. On desktop, it means that the user needs to worry about window management, an exercise task that further disrupts his flow. If users must constantly shuttle between windows to achieve their goals, their disorientation and frustration level will rise. They will become distracted from the task at hand, and their effectiveness and productivity will drop. If the number of windows is large enough, the user will become sufficiently disoriented that he may experience navigational trauma. So you may think that 2 monitor is good. Actually, based on this, he will experience navigational trauma also for large windows, because you need to move your eyes up and down. So as much as possible, you want it in a small window, which is on the desktop. He gets those in the interface. Sovereign posture application discussed in chapter 9. So in the next video, we will discuss this. Can avoid this problem by placing all main interactions in a single primary view, which may contain multiple independent panes. So the reason why we started with this chapter, because I found it the most useful in the chapter of this book. So sovereign posture application is the productivity application that you use for flow, in which you enter a state of flow. Because a lot of our application is just a transient application, which means that you only use that temporarily. And there's also a daemon application which runs on the background, which you do not see. So that we will discuss that in the future videos as well. Navigation between panes. So if you do not know panes, just look at your window. Your window have different square, right? So those are panes in the screen. So for this, like this, like it's here, it's a pane in the left side of this. Here, this is a pane, and here the whole thing is a pane. So I hope you see my mouse there. But basically, it's a square part of the screen that divides it. The windows. Windows or views can contain multiple panes adjacent to each other and separated by splitters. In the next chapter, we will discuss it as well further. Or stacked on top of each other and denoted by tabs. Adjacent panes can solve many navigational problems because they provide useful supporting functions, links, or data on the screen in close reach of the primary work or display area. So this, if you provide this square, because if you do not know, developer actually work with panes when developing application. So if you put that square adjacent to each other, it solves many of the navigation problems, because it provides useful supporting functions, links, or data on the screen, close reach of the primary work or display area. The functions and data, we will also discuss that, but basically that's how we run applications. We input data into a function, and then that function will help us solve our goals, or in this case, like productivity tool, like this OneNote. The data that I put is this text, and then the output, the function allow me to output this presentation. Now this reduces navigation to almost nil. If objects can be dragged between panes, those panes should be adjacent. Problems arise when adjacent supporting panes become too numerous or are not placed on the screen in a way that matches users' workflows. So if you have like a panes that is disorganized or does not relate to each other, or it does not support user workflows, in the future videos we will discuss that further in personas. So in personas, that's where you will find the user workflows on how the user actually navigate your application. So it also about removing excise. So once you have that user workflow, you want to remove the extra steps as much as possible. Too many adjacent panes results in visual clutter and confusion. So if you have a lot of these adjacent panes, it can backfire because again the principle of salient information, we need to be clean. So it confuses. You need to put the most important things. Users do not know where to go to find what they need. So again, you need to support the user workflow and the focus of the customer at the time. You need to follow those cognitive frameworks principle that we've discussed in the previous video. Also, crowding forces scrolling, another navigational hit. So if you crowd the navigational vein, the user sometimes, especially if you don't provide an obvious hint, like the texts are small or it's hard to make sense of the content, then the user forced to scroll instead and then won't be able to find it. Users, let's see. Navigation within a single screen does become a problem. Some web portals trying to be everything to everyone have such navigational problems. So a single page for that took a navigation hit because the developer tries to be everything to every customer. So it wants to serve every persona as possible. If you inhaled the persona, which we will discuss in the future video, you will be able to you will won't experience this because you'll only provide the necessary functions and necessary details on your web apps. In some cases, depending on user workflows, tab panes can be appropriate. So a tab panes, so it's a different kind of organization. Tab panes bring with them a level of navigational excise and potential for user disorientation because they obscure what was on the screen before the user navigated to them. However, this idiom is appropriate for the main work area when multiple documents or independent views of a document are required, such as in Microsoft Excel, see figure 12.1. So these are the dialog box that distracts us. So late in the future video, we will discuss how those affect cognitive exercise as well. So here are tab panes. So this can be useful for certain applications such as this Excel because it allows us to click on different views, such as here you have 4 different view or 4 square, so you can move the views. So for certain application this is useful. So idiom, we will discuss that in the previous future video as well. Idiom is basically different from metaphor, it in which that it's a unique vocabulary such as I forgot what is, but we learned that vocabulary by way of doing things. In the future video as well, we will discuss how intermediate users. So it's like there's a bell curve in which an intermediate user is the most user of our website. So we're optimizing for that intermediate. So those intermediate users came from being a beginner. So that beginner wants to be intermediate. So basically, most of the things that we learn, such as toolbar on your Windows, are an idiom, a mouse click, an idiom, because we've learned this. We did not copy this in real world. So metaphor is things that we copy in real world, and you may think that those will apply in digital world, but not. No, actually, because most of the time metaphor adds to our cognitive load or exercise. Sorry about that. And it does not help. It disrupts flows. So there. Figure 12.1, Microsoft Excel makes use of tab panes visible in the lower left to let users navigate between related worksheets. Excel also make use of splitters to provide adjacent panes for viewing multiple distance parts of a single spreadsheet without constant scrolling. Both these idioms help reduce navigational exercise for Excel users. So here it removes navigational exercise because navigational exercise is the most common issue with perceptual or cognitive load with this technology. Some developers use tabs to break complex product capabilities into smaller chunks. They reason that using these capabilities will somehow become easier if the functionality is cut into bite-sized pieces. Actually, putting parts of a single facility onto separate panes increases excise and decreases users' understanding and orientation. So you meet some developer thinks that cutting one related functions into a smaller chunk will help, but it actually disrupt flow. So the best way is to put that in one pane instead of separate panes because it increases cognitive load and decreases users' understanding and orientation. The use of tab panes screen areas is a space-saving mechanism and is sometimes necessary to fit all the required information and functions into a limited space. Settings dialog are a classic example. So, a tab screen areas could is an example of a settings dialog. So, if you change your settings, you got this tab screen area. It's a space saving and it's a classic example of how this could help. We don't think anyone is interested in seeing all the settings for sophisticated application laid bare in a single view. In most cases, though, the use of tabs creates significant navigational exercise. So, this tab is useful for settings as a space saving. So, just like a menu, to fit all the required information. But you should not do this always because in most cases the use of this create a significant navigational exercise. It is really possible to accurately describe the contents of a tab with a succinct label, though in a pinch rich visual modeless feedback on tabs can help. So this rich modeless feedback, we will discuss this in the next video as well. So basically it allows us to immediately see using like a thumbnail or an immediate symbol that will allow us to recognize the function immediately. So most of the often these contents could not be like the contents of the settings could not be explained in one title or in one symbol. Therefore, users must click through each tab to find the tool or piece of information they are looking for. Figure 12.2 tab palette in Adobe Illustrator allow users to switch between the mixer and swatches. So here, swatches and color, which provide alternative mechanism for picking a color. Tab panes can be appropriate when there are multiple supporting panes for a primary work area that are not used at the same time. The support panes can be stacked and the user can choose the pane suitable for his current task, which is only a click away. So here, just click away. Since it's so it's a tab, you don't see what inside this tab, but it's related to this, so it is helpful in this case. Navigation between tools and menus. Another important and overlooked form of navigation results from a user's need to use different tools, palettes, and functions. Spatial organization of this within a pane or window is critical to minimizing extraneous mouse movements that at best could result in a user annoyance and fatigue, and at worst could result in a repetitive stress injury. So as partial, so the spacing of these related tools, palays, and functions should be uh, optimized, or should be, what do you call this? Should be utilized as much as possible to avoid fatigue. So, a spatial organization that makes sense to the user within a pane or window is critical to avoid these mouse movements, because the space, which we've discussed in the previous video, the amount of movement that our mouse actually add to our cognitive load. Tools that are used frequently and in conjunction with each other should be grouped spatially and also be immediately available. Menus requires more navigational effort on the part of users because their contents are not visible prior to clicking. Frequently used functions should be provided in toolbars, palays, or the equivalent. So toolbars, like in Windows at the bottom, that's your toolbars. So those are the things that has been learned, or are idiom, which we will discuss in the next videos, that proven to be liked by the user. So how do you know if it commonly used by the user? So how do you know if you will make it an idiom unique to your app? You run an analytics or interview to know what your user like. Adobe Photoshop exhibits some undesirable behaviors in how it forces users to navigate between palette controls. For example, the paint bucket tool and the gradient tool each occupy the same location on the tool palette. You must select between them by clicking and holding the visible control, which opens a menu as shown in figure 12.3. So here, these are related tools, so they could have combined it in one click, this gradient tool and patient bucket tool. But in this case, they need you to hold it. When you click it, you need to hold it to go on one, and then uh, uh, and then before it open. So in Adobe Photoshop, the paint bucket tool is hidden in a combo icon button. See chapter 21 on its tool palette. Another thing is that instead of it being hidden, it could have been in, because it's like a menu, you need to click it before you can see the contents instead of that, they can just put that here, because it's a commonly used functions. Even though users make frequent use of both the gradient tool and paint bucket tool, they are forced to access this menu anytime they need to switch between these tools. Navigation of information. Information, or the content of panes or windows, can be navigated using several methods: scrolling or panning, linking or jumping, and zooming. The first two methods are common. Scrolling is ubiquitous in most software, and linking is ubiquitous on the website or web application. Although increasingly linking idioms are being adopted in non-web applications. So sometimes a non-web application such as a productivity tools or a desktop tools, desktop productivity, utilize this linking. Zooming is used primarily to visualize 3D and detailed 2D data. Scrolling is often a necessity, but the need for it should be minimized when possible. Often there's a trade-off between paging and scrolling information. You should understand your users' mental models and workflows to determine what is best for them. So this choice of the method, or the scrolling or linking, should be based on persona. So you need to understand their workflow and mental models. In 2D visualization and drawing applications, vertical and horizontal scrolling are common. These kinds of interface benefit from a thumbnail map to ease navigation. So a thumbnail is like a picture that will allow you to easily recognize what will happen. And then another thing is that in the future video we will discuss how you decide like the research on what's the most useful, whether it's scrolling, linking on your application based on competitors. So you don't want to immediately reinvent the wheel, or as much as possible don't reinvent the wheel. We will discuss that in the previous video. We'll discuss this technique as well as other visual signposts later in this chapter. Linking is the critical navigational paradigm of the web because it is usually dislocating activity. Extra care must be taken to provide visual and textual cues that help orient users. Zooming and panning are navigational tools for exploring 2D and 3D information. These methods are appropriate when creating 2D or 3D drawings and models, or for exploring representations of real-world 2D and 3D environments, architectural walkthroughs, or topography maps. For example, they can fall short when they are used to examine arbitrary or abstract data presented in more than 2 dimensions. Some information visualization tools use zoom to mean display more attribute details about objects. A logical rather than spatial zoom. As the view of the object enlarges, attributes, often textual, appear superimposed over its graphical representation. This technique works great when the attributes in question are tightly associated with spatial data, such as that employed in Google Maps. So, here when you zoom, you get more information. But for abstract data spaces, this kind of interaction is almost always better served through an adjacent supporting pane that displays the properties of selected objects in a more standard readable form. So, for an abstract objects, which is usual website, adjacent panes is better than this 2D or 3D visualization. So this square and then this another square. So that's how you organize it. So here, as the view of the object enlarges, attributes, often textual, appear superimposed over its graphical representation. So this technique works great when attributes in question are tightly associated with spatial data. So spatial data, such as a Google map, you're locating a place. So that's useful for this zooming and in and out. Some information visualization tool used to mean display more attribute. A logical rather than spatial zoom. So here, when you zoom in, you're asking for more details. A logical, so which is not applicable in 2D because you're asking for detail. Usually, if you zoom in, you only enlarge the object or the picture. You're not getting more details. Figure 12.4, the Google Maps apps makes excellent use of a combination of spatial and logical zoom. As the user physically zoom in by spreading his fingers apart on the map, location details such as transit lines, traffic congestion, street names, and places of business also come into view. Zoom usually works best when applied to concrete rather than abstract data spaces such as maps. Panning and zooming, especially when paired, create navigational difficulties for users. So panning is like in 3D where you check different views of the object, and then when you add zooming, which is the most cognitive work, it provides a lot of navigational difficulties. Although this situation is improving due to the prevalence of online maps and easy to grasp gestural interfaces, it is still possible for people to get lost using virtual spaces. Humans are not used to moving in unconstrained 3D environments, and they have difficulty perceiving 3D properly when it is projected on a 2D. So since we're not used in a 3D such as this applied in digital tools that is unconstrained, because it's not limited by physical laws, just like in what we do in the real world. You know, when you jump at the window or at the second floor, you'll break your bones. But in this 3D, Applications, you won't. So we're not used to that. Especially we're navigating it using a 2D interface, such as this laptop or computer. Skeuomorphic excise. So here we are experiencing an incredible transformation from the age of industrial mechanical artifacts to an age of digital information objects. As the history of the Industrial Revolution shows, the fruit of new technology can often only be expressed at first with the language of an earlier technology. For example, we called railroad engines iron horses and automobiles horseless carriages. Sometimes this appropriation of the old is valid because the function is identical, even if the underlying technology is different. For example, when we translate the process of typing with a typewriter into doing word processing on a computer, we're using a mechanical representation of a common task. Typewriters used little metal tabs to rapidly move the carriage several spaces until it came to rest on a particular column. The process, as a natural outgrowth of the technology, was called tabbing or setting tabs. Word processors also have tabs because their function is the same. Whether you are working on a paper rolled around a platen or on images on a video screen, you need to rapidly slew to a particular margin offset. Mechanical procedures are usually easier to perform by hand than they are with digital products. Consider a simple contact list. If it's faithfully rendered on screen like a little bound book, it will be much more complex, inconvenient, and difficult to use than the physical address book. The physical address book, for example, stores names in alphabetical order by last name. But what if you want to find someone by her first name? The mechanical artifact doesn't help you. You have to scan the page manually. The faithfully replicated digital version wouldn't search by first name either. The difference is that on the computer screen, you lose many subtle visual and tangible cues offered by the paper-based book, bent page corners penciled in notes. Meanwhile, scroll bars, swipe to delete, and navigational drill downs are harder to use, harder to visualize, and harder to understand than simply flipping pages. Designers paint themselves into a corner when they rely on slavishly skeuomorphic metaphors. So this is what I'm saying, where we translate functions in mechanical age to digital tools, which is too constraining. Visual metaphors such as desktops with telephones, copy machines, staplers, and fax machines, or file cabinets with folders in drawers may make it easy to understand the relationships between interface elements and behaviors. But after users learn these fundamentals, managing the metaphor becomes an exercise in excise. For more discussion on the limitations of visual metaphors, see chapter 13. So we'll discuss that in the videos. We've discussed the intro of that, which I said that the metaphor most often does not work because we often learn this behavior through using them because we want to be intermediate users. We don't want to be beginner, especially for productivity tools. Screen real estate consumed by skeuomorphic representations is also excessive, particularly in sovereign posture applications. So this sovereign posture is the productivity where we enter flow. We're maximizing screen space for content rather than UI crew is of primary importance. So in this kind of application, we want to provide a lot of functions in one window because the user wants to achieve something. It wants function, not beauty. So you don't want to disrupt flow just because you want to make the color amazing. The little telephone that so charmingly told us how to dial on that first day long ago is now just a barrier to quick communication. It's all too easy to fall into the trap of skeuomorphic excise in the name of user-friendliness. Apple's iOS veered uncomfortably in the direction of skeuomorphism for versions 4, 5, and 6, but it seems to have fully snapped out of it in iOS 7. So here, Apple copied the skeuomorphic or mechanical age of having newsstand, but now it allows the digital tools do its magic. Modal exercise. Flow is a natural and people enter it without much prodding. It takes some effort to break into flow after someone has achieved it. Interruptions like ringing a telephone will do it, as will a modal error message or confirmation dialog. Some interruptions are unavoidable, but interrupting the user's flow for no good reason is stopping the proceeding with idiocy and is one of the most disruptive forms of excise. An application cheerfully execute an impossible query that brings up your system until you decide to reboot. Users view such software behavior as idiocy and with just cause. The Stein principle: don't stop the proceedings with idiocy. So don't, again, that error message we encountered earlier, don't do that to your user. Errors, notifiers, and confirmation messages. These are so ubiquitous that eradicating them takes a lot of work. In chapter 15, we discussed these issues at length, but for now, suffice it to say that they are high in excise and should be eliminated from your applications whenever possible. It either tells the user something he doesn't care about or demands that he fix a situation that the application can and should usually fix just as well. So the application, such as what we will discuss in the future videos, what we call demonic application, which runs in the background, could definitely fix that itself. Instead of asking users, try to observe users in their everyday behavior and see what they do. So if they don't need that dialog box, you need to apply a demonic application that will do that for them instead of showing this dialog box. Figure 12.6 shows an error message box displayed by Adobe Illustrator 6 when the users try to save a document. We're not exactly sure what it's trying to tell us, but it sounds dire. Here, there was a problem with the log file. QuickBooks Web Connector will continue without a log file. The message stops an already annoying and time-consuming procedure, making it even longer. So the productivity or function that the user wants to do this is already long, and then this error dialog box makes it longer. So this is a productivity tool. So the user are in the state of flow, and this what it does for already long function. A user cannot fetch a cup of coffee after telling the application to save his artwork because he might return only to see the application incomplete and the application mindlessly holding up the process. We discuss how to eliminate these sorts of messages in chapter 21. Figure 12.7, here's a horrible confirmation box that stops the proceeding with idiocy. If the application is smart enough to detect the difference, why can't it correct the problem itself? The option the dialog offers are scary. It is telling you that you can explode one of two boxes. One contains garbage and the other contains the family dog, but the application won't say which is which. And if you click cancel, what does that mean? Will it explode your dog? So rules created in this profile conflict with rules on the Microsoft Exchange server. Only one set of users can be saved. Which rules do you want to save? Client, server, cancel. This dialog is asking you to make an irreversible and potentially costly decision based on no information whatsoever. If the dialog occurs just after you change some rules, doesn't it stand to reason that you want to keep them? And if you don't, wouldn't you like a bit more information, such as exactly what rules are in conflict and which of them are the more recently created? You also don't have a clear idea what happens when you click cancel. Are you canceling the dialog and leaving the rules mismatch? Are you discarding recent changes that led the mismatch? The kind of fear and uncertainty that this poorly designed interaction arouses in users is completely unnecessary. We discuss how to improve this kind of situation in chapter 21, which is in the next videos. Making user ask permission. Back in the days of command lines and character-based menus, interfaces indirectly offered services to users. If you wanted to change an item such as your address, first you had to ask the application for permission to do so. So in command line before, So this is what we've discussed in the interfaces chapter in the previous video. You need to, since the interfaces offer services directly, you need, they ask you permission each time, and you need to remember the command. So the application would then display a screen where you could change your address. Asking permission is pure exercise, and unfortunately, things haven't changed much. If you want to change one of your saved address on Amazon.com, you have to click a button and go to a different page. If you want to change a displayed value, you should be able to change it right there. You shouldn't have to ask permission or go to a different room. Design principle, don't make user ask permission. As in the preceding example, many applications have one place where the values such as file names, numeric values, and selected options are displayed for output, and another place where user input to them is accepted. This follows the implementation model, which treats input and output as different processes. So, a lot of our applications which has values for file names, numeric values, and selected options are displayed for output, and another place where user input to them is accepted. So here's another exercise because it treats the users as knowledgeable like a developer. So it thinks that it knows the output, process, and input. This follows the implementation model, which treats input and output as different processes. A user's mental model, however, don't recognize a difference. He thinks there is a number, just click it and enter a new value. If the application can accommodate this impulse, it is needlessly inserting excise into the interface. If the user can modify options, he should be able to do so right where the application displays them. Design principle, allow input wherever you have output. So in affordance chapter, we will discuss this, in which you will make the icon or button as obvious as possible, and then allow that to be the input. And then you provide that output or immediate feedback to remind or to provide awareness that the user successfully provided input. Because like what we've discussed in the previous chapter or in the previous video, if you don't have feedback, then it's hard to know how you are progressing. So the opposite of asking permission can be useful in certain circumstances. Rather than asking the application to launch a dialog, the user tells a dialog to go away and not return. In this way, the user can make an unhelpful dialog stop bothering him, even though the application mistakenly thinks it is helping. Microsoft Windows now makes heavy use of this idiom. So there's an idiom in which instead of asking permission, the user allow to put a check mark to never ask again, such as in deleting files. I know you have experienced that, or most of you. So if a beginner, where are we? Rather than asking application to launch a dialog, the user tells a dialog to go away and not return. In this way, the user can make an unhelpful dialog stop bothering him, even though the application mistakenly thinks it is helping. So as you can see, guys, these are the things that these companies or technology companies did to make the user experience better. That's why now it's seamless. And before the Windows or doing or using the application, it's so hard, especially for command line. So programmers are so highly paid because they understand this intuitively, this cognitive load. Microsoft Windows now makes heavy use of this idiom. If a beginner inadvertently dismisses a dialog and can figure out how to get it back, he may benefit from another easy-to-identify safety net idiom in a prominent place. I help menu item saying bring back all dismissed dialogues, for example. Stylistic style. Users must perform visual work to decode on-screen information, such as finding a single item in a list, figuring out where to begin reading on a screen, or determining which elements on a screen are clickable and which are merely a decoration. So, a user also creates a lot of cognitive energy when performing visual work to decode on-screen information. So you want to make it as obvious, as seamless. It's kind of like not disrupting their flow. So you want them to focus on the content, on the function, on what they want to achieve with their goals. Figuring out where to begin reading on a screen, or determining which elements on a screen are clickable and which are merely decoration. So which are clickable, that can be solved by affordance, which we will discuss in the future videos. A significant source of visual work is the use of overly styled graphics and interface elements. See figure 12.8. Visual style can create mood and reinforce brand, but it shouldn't do so at the expense of utility and usability by forcing users to decode visual elements to understand which represents control and critical information and which are merely ornamental. So usually your app is sovereign application, which means you should not disrupt flow. So you should not let the visual elements disrupt the function that you want your user to do. So you should not make this that obvious, not overly colorful or overly destructive, that it defies the purpose that you initially set out to do. The use of visual style, at least in apps geared toward productivity rather than entertainment, should support the clear communication of information and interface behavior. So instead of having this fancy design, have clear communication interface for its function that do not disrupt flow. Figure 12.8, the homepage of the Blue Bell Creameries, provides a good example of visual exercise. Text is highly stylized and doesn't follow a layout grid. It's difficult for users to differentiate between decor and navigational elements. This requires users to do visual work to interact with the site. This the user needs to know what is clickable. So it needs to use its eyes, which a lot of cognitive load, which we discussed in the previous video. This isn't always a bad thing. Just the right amount of the right kind of work can be a source of entertainment, as with games and puzzles. For more discussion on striking the right balance to create effective and visual interface design, see chapter 17. So we will discuss the balancing of interface design or visual interface in the next videos. Exercise is contextual. One month's or persona's goal-directed task may be another exercise task in a different context. In general, a function or action is exercise if it's forced on the user rather than made available at his discretion. So the user does not intend to do those extra tasks. That is exercise, and exercise is different for different users, as we will discover in the next videos, which different personas has different goals. An example of this kind of function is window management. The only way to determine whether a function or behavior such as this is exercise is by comparing it to persona's goals. If a significant persona needs to see two applications at a time on the screen to compare or transfer information, the ability to configure the main windows of the applications so that they share the screen space is not an exercise. So again, we need to start with personas. That's the only way we know if it's an exercise or not, because we need to measure it. We need to see how people use the product. If a significant persona needs to see two applications at a time on the screen to compare or transfer information, the ability to configure the main windows of the application so that they share the screen space is not exercise. So if the persona has the ability to configure the main windows so that they can share the screen because he needs to see the two application at a time, then it's not an exercise. Just kind of like the Windows function, this that allows you to have two window at a time. If that's your goal, then it's not an exercise. If your personas don't have this specific goal or need, the work required to configure the main window of either application is exercise. So if it doesn't need it, it's an exercise because it removes the space to otherwise relevant information. Exercise may also vary by software posture. See Chapter 9. Users of transient posture applications often require some instruction to use the product effectively. Allocating screen real estate to this effort typically does not contribute to exercise in the same way as it does in sovereign posture applications. So transient applications are those applications that you rarely use. So those could have the user could have more patience in having a lot of exercise in that, because it's understandable that you have to relearn it because you're not using it every day. Transit posture applications aren't used frequently, so their users need more assistance understanding what the application does and remembering how to control it. So you can be extreme here by providing big text size or large icons to really provide the meaning of your function, unlike a sovereign application in which the user always use it. Because if you have a large text and large icons, it is distracting and provides a lot of exercise for sovereign applications. So it's different for different posture of applications. However, some types of actions are almost always exercise and should be eliminated under all circumstances. These include most hardware management tasks that software could handle itself if a few more design and engineering cycles were spent on it. So this is what we are telling earlier, which is the configuration part of or the settings, the hardware management, the environment settings in development environment for developers. This should be done using a daemonic application, or at least be included in the overall design of the app in the engineering cycle. It should not be placed on the user. Any demands for such information should be struck from user interfaces and replaced with more silently intelligent application behavior behind the scenes. Eliminating excise. So these are the ways that we can eliminate excise. Navigational excise is easily the most prevalent type of excise found in digital products, and thus is one of the best places to start eliminating it. There are many ways to begin improving, eliminating, reducing, or speeding up navigation in your applications, websites, and devices. Here are the most effective. Reduce the number of places to go. The most effective method for navigation sounds quite obvious. Reduce the number of places to which one must navigate. These places include modes, forms, so forms as well should be minimized, dialogues, pages, windows, and screens. Modes as well. If the number of modes, pages, or screens is kept to a minimum, people's ability to stay oriented increases dramatically. In terms of the 4 types of navigation presented earlier, this directive means you should do the following. Keep the number of windows and views to a minimum. One full screen window with 2 or 3 views is the best for many users. So the views which in Excel provided earlier, such as 2 to 3, is best for many users. Keep dialogues, especially modeless dialogues, to a minimum. Applications, websites, or mobile apps with dozens of distinct types of pages, screens, or forms are difficult to navigate. Limit the number of adjacent panes in your interface to the minimum number needed for users to achieve their goals. The adjacent panes, which provide functions, limit it to a minimum and make sure it's logical. In sovereign posture applications, 3 pane is a good thing to shoot for in each page. But there are no absolutes here. In fact, many applications require more. On web pages, anything more than 2 navigation areas or 2 navigation panes and 1 contact area begin to get busy. On tablet apps, 2 pins is difficult. So 2 pins in a tablet apps because it's small screen. As you can see, it's divided into rectangle. Limit the number of controls to as few as your users really need to meet their goals. Having a good grasp of your users via persona will enable you to avoid functions and controls that your users don't really need, want or need, and that therefore only get in their way. So in the next chapter we will discuss how adding more functions or buttons or screen does not really help our customers, because a lot of developers or people think that the quality of application is based on the number of functions it can provide, which is actually not true. Minimize scrolling when possible. This means giving supporting panes enough room to display information, enough information or function in each pane so that they don't require constant scrolling. Default views of 2D and 3D diagrams and scenes should be such that the user can orient himself without too much panning. Zooming is the most difficult type of navigation for most users, though more straightforward in mobile apps using pinch gestures. So zooming is the most difficult, like we've said, what I've said, but it's the most common in mobile apps. So its use should be discretionary, not a requirement. Many online stores present confusing navigation because the designers have tried to serve everyone with one generic site. If user buys books but never music from a site, access to the music portion of the site could be de-emphasized in the main screen for that user. This makes more room for that user to buy books, and the navigation becomes simpler. Conversely, if he visits his account page frequently, his version of the site should prominently display his account button or tab. So, conversely, if he visits his account page frequently, his version of the site should display the account button or function or tab. Provide signposts. In the same way that sailors navigate by reference to shorelines or stars, users navigate by reference to persistent objects placed in a user interface. Persistent objects in a desktop world always include the application's windows. So these windows is a learned idioms. Each application most likely has a main, top-level window. The salient features of that window are also considered persistent objects. Menu bars, so these are the silent but are accepted as consistent in all desktop interface. Menu bars, toolbars, and other palette or visual features like status bars and rulers. Generally, each window of the interface has a distinctive look that will soon become recognizable. Well-designed websites make careful use of persistent objects that remain constant throughout the shopping experience, especially the top-level navigation bar along the top of the page. Here, the search bar and the top-level navigation. Not only do these areas provide clear navigation options, so at the top page you have this navigation bar, like this option or different category. Not only do these areas provide clear navigational options, but their consistent presence and layout also help orient customers. The design within Rich website make use of many persistent areas on the majority of its pages, such as the links and search field along the top and the browser tools on the side. This does not only help users figure out where they can go, but also help keep them oriented. In devices, similar rules apply to screens, but hardware controls themselves can take on the role of signpost, even more so when they offer visual or tactile feedback about their state. So, a signpost can also be a visual or tactile feedback that will change its color or provide audio feedback. So, it applies also to devices such radio buttons that, for example, light when selected, even a detailed position on a dial, can provide navigational information if integrated appropriately with the software. Depending on the application, the contents of the applications main window may also be easily recognizable, especially within kiosk and small screen devices. So the content of the main window are easily recognizable for kiosk and especially for small screen devices. Some application may offer a few different views of their data, so the overall aspect of their screen changes depending of the views chosen. So the common theme here is just 2 to 3 views, or the rule of 3, the maximum of 3 views. And then you want to provide those different views with different input or data to provide those different aspects or signposts. A desktop application distinctive look, however, usually comes from its unique combinations of menus, palettes, and toolbars. You don't need a lot of signposts to navigate successfully. They just need to be visible. So you don't need to have a lot, such as in desktop, you only have these fixed signposts, menus, palettes, and toolbars. They just need to be visible and recognizable when the user needs it, because again, you don't want to disrupt their flow with those annoying color. Needless to say, signposts can aid navigation if they are removed, so it's best if they are permanent features of the interface. Some iOS browsers break these rules slightly by allowing controls to scroll up as the user moves down the page. However, they immediately scroll back down when the user reverses a direction. A clever means of bringing controls back into focus as soon as they are needed, making each page on a website looks like just every other one may maintain visual consistency. But it can, if carried too far, be disorienting. So it depends on your personas. You should use differentiator when it's needed. You should use common elements consistently on each page, but making different rooms look distinctive, you will help orient your users better. Menus. The most prominent permanent object in a desktop application is the main window and its title and menu bars. Part of the benefit of the menu comes from its reliability and consistency. Unexpected changes to an application's menus can deeply reduce users' trust in them, so you should really change its function. This is true for menu items as well as for individual menus. So it's true for menu items and then individual menus, because remember, you can have different menus on your web apps. Toolbars. If the application has a toolbar, it should also be considered a recognizable signpost, because toolbars are idioms for perpetual intermediates rather than for beginners. The strictures against changing menu items don't apply quite as strongly to individual toolbar controls. Since toolbar targets the intermediates, uh, they can configure that definitely, but you should not change that frequently. You should have at least fixed or consistent toolbar, just like in menu. Unexpected changes to an application's menu can deeply reduce users' trust in them. This is true for menu items as well as for individual menus. Toolbars. If the application has a toolbar, it should also be considered a recognizable signpost, because toolbars are idioms for perpetual intermediates rather than for beginners. The strictures against changing menu items don't apply quite. Sorry, we repeated. Yeah. Other interface signposts, tool palettes, and fixed areas of the screen where data is displayed or edited should also be considered persistent objects that add to the interface navigation is. Judicious use of white space and legible fonts is important so that these signposts remain clearly evident and distinctive. So, other signposts is a tool palette and a fixed areas in screen unique to your interface where data is displayed or input is displayed or edited, and should be considered persistent objects that add to the interface navigational ease. So you want to provide consistency. So judicious use of white space and legible font is important so that these signposts remain clearly evident and distinctive. So later in the previous video, we will discuss the best font that is readable, and how we would use this white space and contrast to make this input afford affordable. No, that's not affordable, but the affordance concept where you make it obvious. Provide overviews. The difference is that overviews help orient users within the content rather than within the application as a whole. So the difference of these overviews with signposts is that it helps orient users with the content rather than within application as a whole. So within the content, you have an overview that immediately tells, kind of like the title of a paragraph. You know what's the paragraph mean based on the title or the content. The content of the paragraph. Yes, because of this, the overview area should itself be persistent. Its content is independent on the data being navigated. So the title bar or the position of that title should be consistent. The data could change of the content or the function, the input and output, but they should be consistent overviews. Overviews can be graphical or textual depending on the nature of the content. An excellent example of graphical overview is the aptly named Navigator Palette in Adobe Photoshop shown in figure 12.10. So here you have Navigator, Histogram, Info tab, which provides you an immediate overview. Here you have an overview when you click this. So when you go here, for Analytics for Stock Market for Google. On the left side, Adobe makes use of an excellent overview idiom in Photoshop, the Navigator Palette, which provides a thumbnail view of a large image within an outline box that represents the portion of the image currently visible in the main display. This is the actually the overview. This is a tab. So this is the overview which highlights it immediately when you click Navigator. Not only does the palette provide navigational context, but it can be used to pan and zoom the main display as well. A similar idiom is employed on the right in the Google Finance charting tool, in which smaller graph on the bottom provides a big picture view and content for the zoom in view on the top. So here's the zoom in view. In the web world, the most common form of overview is textual. So here, where is that? I think I haven't captured that, but here the ubiquitous breadcrumb display. Again, most breadcrumbs provide navigational aid as well as a navigational control. Not only do they show where in the data structure a visitor is, but they also give him or her tools to move different nodes in the structure in the form of links. So here, like, you will see where you navigate in the page. So that was supposed to be the picture, but I forgot. But I know when it's like another thing that you call this is the click path, where you know where you are in the web page. So you can just click on the previous click path to go there. So that's what it means. Not only do they show where the data structure visitor is, but they also give him or her tools to move to different nodes in the structure in the form of links. This idiom has lost some of popularity as websites have moved from being strictly hierarchical organizations to more associative organizations which don't lend themselves as neatly to breadcrumbs. So a typical breadcrumb displayed from Amazon.com, users see where they've been and click anywhere in the breadcrumb trail to navigate that link. So that's the click path. Final interesting example of an overview tool is the annotated scroll bar, which is most useful for scrolling through text. They make clever use of the linear nature of both scroll bars and textual information to provide location information about the locations of selections, highlights, and potentially many other attributes of formatted or unformatted text. So you see the scroll bar here, you see where you are in the page and the page number and the context, behavioral and interface level. An annotated scroll bar from Microsoft Word provides useful context for the user as he or she navigates through a document. Hints about the locations of these items appear in the track that the thumb of the scroll bar moves in at the appropriate location. When the thumb is over the annotation, the annotated feature of the text is visible in the display. Microsoft Word uses a variation of the annotated scroll bar. It shows the page number and nearest header in a tooltip that remains active during the scroll, as shown in figure 12.12. Properly map controls to functions, so making it clear, not do not make your user think what the function means, because again it added cognitive load, it disrupted flow. Mapping describes the relationship between a control, the thing it affects, and the intended result. Poor mapping is evident when a control does not relate visually, spatially, or symbolically to the object it affects. So if it does not relate visually, spatially, the positioning, and symbolically, or the icon, which we will discuss in the next videos, then it will result in poor mapping. Poor mapping requires users to stop and think about the relationship, breaking flow. Poor mapping of controls to functions increases the cognitive load for users and can result in potentially serious user errors. Norman provides an excellent example of mapping problems from the digital world in the design of everyday things, basic books in 2022. Almost anyone who cooks has run into the annoyance of a stovetop whose burner knobs do not map appropriately to the burners they control. In this case, we have physical mapping problem. The result of using the control is reasonably clear. A burner will heat up when you turn a knob. However, the target of the control, which burner will get warm, is unclear. This cognitive work may become habituated over time, but it still exists, making users prone to error if they are rushed or distracted, as people often are while preparing meals. The solution requires moving stove top knobs so that they better suggest which burners they control. The knobs don't have to be laid out in exactly the same pattern as the burners, but they should be positioned so that the target of each knob is clear. The stove stop shown in figure 12.14 is a good example of an effective mapping of controls. So here, clear spatial mapping, the positioning, you know exactly that this or this for here, this are for here, these are for here, etc. On this stove, it is clear which knob maps to which burner because the spatial arrangement of knobs clearly associate each knob with the burner. Here, an example of a logical mapping problem. If the user wants to see the most recent items first, does she choose ascending or descending? These terms don't map well to how users conceive of time. While here, clear, logical mapping, most recent, and oldest are terms that user can easily map to time-based sorting. Avoid hierarchies. So we will discuss this implementation model in the data storage part, in which we don't see the hierarchy the same way as the user. So developers like us don't see it that the user don't see that because we rarely see nested objects or hierarchies in the physical world. So you rarely see hierarchies are one of the developers' most durable tools. Much of the data inside applications, along with much of the code that manipulates it, is in hierarchical form. So much of the data that we and the code is in hierarchical form. For this reason, many developers present hierarchies, the implementation model, in user interfaces. So that's the implementation model that we are talking about. It's different in unified model, which we will discuss in the next videos. Early menus, as we've seen, were hierarchical. Most humans are familiar with hierarchies in their business and family relationships. But hierarchies are not natural concepts for most people when it comes to storing and retrieving arbitrary information. Because when you place your book in like a shelf, that is the storage and that's how you retrieve this. You remember the location, but it's different in a nested folder in your web app, which we will discuss in the future videos. Most mechanical storage systems are simple, composed of either a single sequence of objects like a bookshelves or a series of sequences, one level deep like a file cabinet. Developers are comfortable with nested systems in which an instance of an object is stored in another instance of the same object. Most other humans have a difficult time with this idea. In the mechanical world, complex storage systems by necessity use different mechanical form factors at each level. In a file cabinet, you never see folders inside folders or file drawers inside file drawers. Computer science gives us hierarchical structures as tools to solve the very problems of managing massive quantities of data. So, in computer science, we actually use this in data structures and algorithms to solve this huge data, but it is not common sense in the real world, so you should not inflict that to the user. The solution to this conundrum is to render the structure as the user imagines it, as monocline grouping, but to provide the search and access tools that only a deep hierarchical organization can offer. So since the humans could not remember like a million books and then remember each place, the advantage of this digital or hierarchical organization is you can search it with attributes such as name, the date. In other words, rather than forcing users to navigate deep complex tree structures, give them tools to bring appropriate information to themselves. We'll discuss some design solutions that help make this happen in chapter 14. Don't replicate mechanical age models. As already discussed, skeuomorphic excise resulting from an unreflective replication of mechanical age actions in digital interfaces adds excise. Navigational and otherwise, how can the new digital version be streamlined and adapted to take full advantage of the digital environment? How can excise be eliminated and smarts brought to bear? Take the desk calendar. In the non-digital world, calendars are made of paper and are usually divided into a 1 month per page format. This is a reasonable compromise based on the size of paper file folders, briefcases, and desk drawers. Paper calendars show a single month because they are limited by the size of the paper, and a month is a convenient breaking point. High-resolution digital displays are not so constrained, but most designers copy the mechanical artifact faithfully, as shown in figure 12.17. Similarly, the grid pattern in digital calendars is almost universally a fixed size. Why can't the width of columns of days or the height of rows of weeks be adjustable like a spreadsheet? Certainly, you won't want to adjust the sizes of your weekends to reflect their reflective importance in relation to your weekdays. So here, we again impose the mechanical way. But here, as you can see, you're able to adjust the size of the square that is not limited by our physical papers. Here you can also see different tabs which allows you to scroll to different months, which is not possible in the paper type. Figure 12.18, scrolling is a familiar task to computer users. Why not replace the page-oriented calendar with a scrolling one to make it better? This perpetual calendar can do everything the old one can, and it also solves mechanical representational problem of scheduling across monthly boundaries. So as we already know, scrolling is the one of the most useful, such as scrolling, panning, linking. So those are one of the most useful. Why not use that? Don't drag old limitations onto new platforms out of habit. What other improvements can you think of? Design principle: significant change must be significantly better. Other common excise traps, these myriad little extra necessary steps can add up to a lot of extra work for users. This list should help you spot excise transgressions. Don't force users to go to another window to perform a function that affects the current window. So if you have same function that is categorized in the in different window, but it should be in one window, then you should not put that in another window. Don't force users to remember where they put things in the hierarchical file system. So don't let them remember a million books in a bookshelf. Don't force users to resize windows unnecessarily. When a child windows pops up on a screen, the application should size it appropriately for its contents. Or better, can you put that in adjacent panes that will make it more logical? Don't make it big and empty or so small that it requires constant scrolling. Don't force users to move windows. If there is open space on the desktop, put the application there instead of directly over some other already open applications. So if you want to move the windows, then just put the function inside on that one web page. Don't force users to re-enter their personal settings. If the user has ever set a font, color, indentation, or sound, make sure that she doesn't have to do so again unless she wants a change. So again, it's important to know our persona, because once they set this settings, they don't want to do this again. They want to focus on the function. Again, it's the importance of understanding what your users want to achieve. Don't force users to fill in the details to satisfy some arbitrary measures of completeness. If the users want to omit some details from the transaction entry screen, don't force him to enter them. Assume that he has a good reason for not doing so. In most instances, the completeness of the database isn't worth badgering users over. So some field should be allowed. So I know that some of you even today in your job application, you usually have to fill all the required field. So just put the required field and let the other be a default. Don't force users to ask permission. This is frequently a symptom of not allowing input in the same place as output. So again, putting the function, the entire function, and not having your user to think like developer, or putting an input and function in one interface could solve this permission issue. Or putting a daemonic application in the background to answer or fix that for them. Don't ask users to confirm their actions. This requires a robust undo facility, which we will discuss in the future videos. So don't ask them to confirm. So instead of having to confirm, let them do it and just provide an undo functionality. Don't let the user's action result in an error. So don't put an error. Just let them undo it. XS represents the most common and most pernicious barriers to usability and user satisfaction in digital products. Again, we will discuss the future topic in the future videos. Thank you for watching and see you on the next video. Peace.